We'll be starting up in about 2 minutes. Good morning. We're going to be starting up in just a little over a minute. So good morning. My name is David Orr. I'm the director here at the New York State LTAP Cornell Local Roads program. And I just want to welcome you to one of our Y foundational webinars. Today we're going to be talking about pavement maintenance. It's a full hour, so be aware of that. Our speaker today is going to be John Rondinero. He's with State DOT for 36 years, and he can tell you a little bit more about himself. I know he's got a lot to do. Make sure you open up your pods, your chat pod and your Q&A pod, because the chat pods where you get a link for our handout and poll questions, and the Q&As where you can put your own answers in. So with that, John, I'm going to let you go ahead and get started because I know you got a lot to cover.
Awesome. Thank you, David. Again, thank you, David. Good morning, everyone. Welcome to our Cornell Local Roads program webinar series. As David mentioned, my name is John Rondinero, and I'll be your tour guide today for our session on common pavement maintenance techniques. Before we get started, I just want to say a quick thank you to David and his team. They are a fantastic bunch of pros. They've done they're great to work with, and they've done a fantastic job getting me set up and ready to present today. So I really want to thank them. That they're great. And I'm really glad that we've got a lot of folks participating today. Just as a little bit of quick background, I'm a retired New York State DOTer for a couple of years now. I had a bunch of different roles over my career at DOT, and I spent most of the 1990s in our main office highway maintenance division, including a couple of years as the state's pavement maintenance program engineer. And then I finished out my time at DOT with 15 years as the department's director of materials engineering. So I got around a lot in 36 years. As I mentioned, the topic of today's session is pavement maintenance. It's a topic near and dear to me. We've got a ton of territory to cover today in an hour, so we're going to be running through things real quick. And our goal today is just to provide a high-level overview of the basics. We really want to focus on why the timing and the correct choice of our pavement maintenance actions is a key to keeping our roads and streets in good shape. But before we jump into it, let's take care of a couple housekeeping items. First, this session is based on a workbook that was developed by David and Gary Nelson, a previous maintenance circuit rider. They developed a workbook for our full-day pavement maintenance workshops, and we'll be holding the 2020-22 sessions in April, and we'll talk a little bit more about the workbook and the workshops in a second. And next, I just want to cover a couple things about using Zoom today. David already referred to these, but let's touch on them again. You should see a toolbox like this at the bottom of your screen. And the three key features, the chat button, that's disabled. We'll be putting in our reference materials in there, stuff that we want to share and you can download. We'll put the workbook, a link to the workbook in the chat. But if you want yourself a hard copy, just email us. We'll also put our email address in there, and just email us, let us know you want the workbook. But no matter which way you get it, whether it's download or a hard copy, get your hands on it. We think it's a great resource. Next is the raise hand feature. We use that occasionally today. Let's see if we can make that work. Everybody just hit your raise hand. All right, great. David, was that looking like it was working?
Yep, everything was going good.
Awesome, good. And then the Q&A, that's where we'll ask you to put any of your comments or questions, or any of the other items that that you want to share with us, and we'll monitor them and get through them, get to them as we go through the session today. All right, moving on. For any of the New York State PEs in the audience today, this is considered a course, so it's eligible for 1 PDH in New York State. However, only the person who's registered is eligible for the PDH. The way this is going to work for everybody in attendance, if you stay through three quarters of the session, we'll send you a certificate of attendance. And then for any of the PEs that want a PDH, we'll ask you to send that certificate back to us with a request, and we'll get you your PDH. For folks from other states, welcome. Thank you for joining us. However, you're going to have to check with your individual LTAP center regarding eligibility. And we're going to use another tool, a poll EV. I think looks like most folks are already logged in and using it. We're going to use this to get a sense of who's in the audience today. And our first question is about what organization you work for. So we've got a nice variety of folks from different agencies and organizations join us today. The only thing that bothers me is there's nobody, that's working for the weekend except me then. Wow, that's pretty scary. There we go. We got at least one. Now we're getting some more people who are being a little more honest. Excellent. Thanks. Let's move on to our next question. My job is, and let's see what roles and responsibilities different folks have. All right, nice. Good bunch of engineers, highway supers, or DPW commissioners, administrators. It looks like we've got some field folks with us today. Excellent. Looks like a nice wide range of folks joining us today. Thank you, appreciate it. And let's do the next one. Let's get a handle on folks' experiences. Nice wide range of experience. We've got some seasoned vets, and we've got some folks that are newer to the game. So that's great. We're glad everybody could join us. I think this will be valuable for all of us. All right, and then let's get a sense of the where geographic, folks are geographically located. If you just click on the map. All right, starting to populate. All right, nice spread of folks across the state. Great. Now, the only thing I'm disappointed in is I usually, I thought we had somebody out in the Atlantic Ocean, but that's, that's to the east of us. Nobody's on a boat in Lake Ontario. There we go. That's what I always like to see. All right, and then last but not least, got to keep it light. Looking for honest response, and if you answer Dr. Octopus, that's okay, but he's not really considered a superhero. There we go. Yeah. Oh, look at this. Very nice. Excellent. Oh, Deadpool seems to be getting, seems to be running with it. Excellent. Now we got a wide range of DC and Marvel folks, a couple folks with some independent operators. My favorite is the Thing from the Fantastic Four. All right, now let's get back to business. Like we said, we're going to be talking about our common pavement maintenance techniques, and we're going to focus on the three most common repairs we do: crack repairs, patching, and wearing courses. Just want to make the point again, we're basing this workshop on the workbook that was developed for this webinar is based on the workbook that was developed for the workshops. And we'll give you more information about those workshops in a minute, but there's the link, and make sure you get a copy of that workbook. In terms of those workshops, This is the spread. This is where we're going to be this coming spring. And we've got 5 different workshops upcoming. The black is our pavement maintenance. We're going to do an eastern run during the beginning of April, and we're going to do a western swing at the end of April. So get to the website if you're interested. We'd love to see you at the workshops. All right, getting to the basis of why we call these why webinars. We ask the question, why do we do what we do? And start with, why do we even have roads? Well, pretty straightforward. We need to be able to move people and goods from point A to point B. It's the backbone of our economy. To do that, we need good roads and pavements, and we really need to, we always point out, you always need to consider your costs when you're making your pavement program decisions. So in terms of your pavement program, we typically use a framework that we refer to as pavement management. And why do we do that? Well, we use this tool to inventory our roads and the conditions, and that becomes the basis of planning and performing our required work. And there's 4 key principles that underlie the pavement management framework. You're really looking to do the right repair at the right place, at the right time, and this is my own personal ad, in the right way. Because you can do all the first 3, and still if you get the 4th one wrong, it's not going to be a good result. So let's ask a quick question. What do you think is the most cost-effective way to keep your road system in good shape? Either applying your pavement maintenance treatments while they're in good shape, or wait until they deteriorate and have to do more extensive rehabilitation. Well, everybody's way ahead of the curve on this one. Everybody's tuned in on pavement maintenance, and that's the key. All right. And just a little bit of background to that. This is a typical pavement deterioration curve. And so up in the upper left, you're starting with a pavement in a brand new or an as like new condition. But over time, that pavement is going to deteriorate, and the quality of that pavement is going to go from better to worse. And then looking at that same curve and overlaying the types of work you can do based on the condition of that pavement, you'll see right in the center that these are the maintenance treatments that we'll be talking about today, and you're performing those treatments while that pavement is still in good shape. But if you let that pavement deteriorate, then you're into those much more extensive activities like pavement rehab or reconstruction. And why is this important? Well, I think you all know that already, but in terms of cost, if you let that pavement deteriorate till it's at the point where it's in poor condition, it's going to cost you 4 to 5 times as much as compared to doing that work while the pavement's in good condition when you can get that pavement maintenance work done. So, to pavement maintenance, why? We've already pretty much answered that. It's those inexpensive repairs on good roads to keep them in good shape. You don't want your pavement looking like that picture. You're also doing it to maintain the safety of the roadway. You're doing it to protect the public's investment. Overall, you're doing it to make best use of your limited resources. And all that together gives you the best bang for the buck. So we want our pavements looking like this and not like this. So there's a handful of common questions you ask when you're thinking about your pavement program. First, do you have enough money in your budget? Now, probably not. I never did. How much can we cut from the budget? Well, if you're starting without having enough, it's real hard to cut. But sometimes you are forced to cut, and you've got to think about those cuts both in the short term and the long term. So when you're thinking about it, you've got to think about, well, can I defer pavement maintenance? And it's real tempting, especially in the short term, to be cutting out your pavement maintenance first. Well, no, that's the last thing you'd want to drop. It's not the first thing you want to consider. So when you finally decided that you're going forward with your pavement maintenance, you ask yourself, what repair should we be using on any particular road? But you've got an underlying question you need to answer, and that's, how's the drainage? And I love this picture. It's a picture David uses in his presentations, with credit to Jay Olson. It says it all. Drainage is critical for roadway design, and ducts are an indicator of poor drainage. That one sticks with me. And if your road looks like this after a rainstorm, you got to be taking care of your drainage issues before you think about any other maintenance. So let's get into the specifics. Let's talk about our repair choices, and we start with that in chapter 3 of the workbook. So you've got a couple different pavement surfaces you'll be working with. The most common in New York is our asphalt surfaces, hot mix asphalt, and you've got a range of options that run from doing nothing all the way to full-blown reconstruction. And you'll notice that our maintenance activities are right there in the middle. Now, we've also got a handful of gravel surfaces or dirt roads still in the state. Some of you may be responsible for those. You've got a range of options that are different than your asphalt pavements. Let's do a quick show of hands. And David, I'll ask you to let me know. Anybody out there have dirt roads or gravel surfaces they're responsible for? Did we see any, David?
We've got about 10.
Oh, so we do have a handful. Okay, well, that's good to know. We are not going to cover these today in the webinar. We do cover them a little bit in the workshop. You do have a range of options. If there is interest in a webinar, let us know and we can look to put together a 1-hour session maybe in the future. All right, but we're not going to talk about them anymore today. In terms of your decision process, it's pretty straightforward and a pretty standard approach. You're going to observe your pavement distresses. You're going to analyze your probable causes. You're going to be evaluating your alternatives, and then you're going to make a decision on what repair you're going forward with. And in this case, you got to ask yourself, did they pick the right repair? All right, let's do another question. Before we select a pavement treatment, what's the fundamental question we need to ask? Let's see what folks come up with. Ooh. Okay, good. Budget, yep, good. Still waiting for the one I want though. How much money do you have? Great, yep. There we go. How's the drainage? First question. Net surface wear? Excellent, excellent. All the right answers, but you really want to ask that first question, you know, that primary question, how's the drainage? All right, folks, thanks. Okay, let's get into our individual repair types, and let's start with crack repairs, and we'll start, that starts in chapter 6 of the workbook. So, quick question, why do we fill or seal cracks in the pavements? And let's see what people think. Good, yep, prevent erosion, prevent water, yep, absolutely, preventive maintenance, stop water infiltration, keep the water out, prevent freeze thaw, excellent, prolong life, yep, all correct. So let's get into it. All right, crack repair, why? Well, you're sealing and filling those openings, those cracks in your pavement surface, and your goal is to prevent or reduce the flow of water and debris, and to prevent and reduce the rate of deterioration. So all of our answers were correct. And there's a handful of factors that we look at when we're talking about crack repair. You're looking at the crack density. How many cracks have you got in a given section of pavement? You're looking at your edge deterioration. What's the edge of that crack look like? Is it a nice square vertical edge, nice clean edge? Or is it all raveled up and coming apart with a vertical sloping vertical slope to the from the edge to the center of the crack, the bottom of the crack? You're looking at your width, and you're looking at the probably most importantly, you're looking at whether that crack is moving or not. So in terms of the types of repairs we can perform, if you look at it in terms of your density and your edge deterioration, if you've got a low density and a low level of edge deterioration, you're probably still in your do nothing area. That doesn't mean you're never going to do anything, but at this point, your timing's just probably not right, and but you got to be watching it close because you're going to quickly move to into the area of crack, into some sort of crack repair work. If you've got moderate density where you've got a handful of cracks and you've got up to a moderate level of edge deterioration, that's where we're going to really start talking about our crack repairs, either sealing or filling. If you've got a high level of crack density and up to a moderate level of deterioration, so that means you got a lot of cracks, but they're still in good shape, you'll be looking at your surface treatments or your wearing courses, and we'll talk about those a little bit later in the session. And then if you've got a high level of edge deterioration, those cracks are real nasty looking, they're all falling apart, and they're starting to pothole, but you've still got low to moderate level of density. You don't have a whole lot of that distress on the pavement. You're really in your arena of patching. And we'll talk more about that in a little bit. And then this is where you don't want to be. If you got a high level of crack density and you got a high level of deterioration, you're really talking about rehab. You're talking about something like a cold in place recycling or mill and fill. And we will not touch on that today. All right, in terms of your specific crack repair activities, you've got your sealing versus your filling. And crack sealing really is targeted at working cracks. That's cracks that are moving based on temperature in the season, in the weather. And that crack is moving more than 1/8 of an inch between the cold of winter and the heat of summer. So when it's cold out, that crack is nice and wide open. And when it's the middle of summer, that crack is nice and tight, and it's really narrowed. And what you're looking at there is, if you're going to be crack sealing it because it's moving, you really don't want to be touching the crack once it gets, you want a minimum of 1/4 of an inch, otherwise you can't get material in there, but you don't want it any greater than 3/4 of an inch. That'll be too wide to really effectively seal. You want minimal to no edge deterioration, because you really want to give a good clean surface for that material to bond to. You're going to be using a modified material, an engineered material, where you're going to add in something like a polymer, and that's going to make that material highly flexible so that it can move with the movement of the crack. And of course, because you're adding a modifier, it's going to cost you more. And then finally, the goal here is really to prevent both the intrusion of water, but primarily debris. Because as you probably all know, in the wintertime, that crack is wide open and you're getting a lot of road junk that's flowing with the water into that crack. Well, as that weather gets better and the temperature starts going up, that side of that crack is narrow, and that side of that crack is going to be pressing hard up against that debris. Well, the debris is breaking down, but so is the side of that crack, and that's going to greatly accelerate the deterioration of and distress on that pavement. In terms of crack filling, again, you're looking at a 1/4 inch minimum, but you can get up to an inch wide because that crack's not moving. And you're looking at non-working cracks, so they're moving less than 1/8 of an inch between your seasons. And you can have up to a moderate level of edge deterioration because that crack is not moving. You're going to be using your conventional materials. You're really not going to be using any kind of polymer modified. And the key here is you're going to reduce the infiltration of water. You really want to make sure that the water's not getting into that crack, and you want to reduce the potential for undermining that pavement. So pretty big differences between the two. And here's an example of a perfect crack repair candidate. Nice straight crack. Not, the edges look like they're in great shape. The sides of that crack are, look like they're, nice, clean and vertical. You don't have any kind of, edge deterioration to speak of. There's no interconnected secondary cracking. Perfect candidate. Here's another example of a crack you'd see on any of our roadways. This is a little further deteriorated. The edges are starting to get a little shaky. You're probably seeing a little bit of sloping to the bottom of the crack, from the edges to the bottom of the crack. It's getting right at the edge of being a good candidate, but still, because there's no interconnected secondary cracking, this is probably still a good, at the end of the window, but it's still a good candidate for crack repair. And wanted to look at this. This is another typical example of what we'd see out in the field. And we want to just go through a quick exercise to show you how you can start to visualize how much material you're going to be placing on the pavement. So you start with your picture, take it back to the office, hit it with your markup tool, with your pen, with the pen, and you can quickly visualize how much repair material you're going to be placing on those cracks. In this case, it looks like it's this is a fairly low density cracking, mostly along the center line. You don't have a lot of interconnected secondary cracking. The cracks look like they're in good shape. The edges are still look in pretty good condition. So this would still be a good candidate. However, as you're looking at that bottom of that slide, you're starting to get some secondary cracking, interconnected cracking. That's going to quickly accelerate. You're going to start developing some potholes. So you need to get on this before no later than the end of the season or early next season. Otherwise, it's going to gone past its window for the crack sealing to be effective. And last but not least, here's an example of something that's missed the window. At one point, it probably was a decent candidate, but now you've got tons of interconnected cracking. They look pretty ragged. A lot of secondary cracking. You've got some potholes forming down in the bottom of the slide. And then you've probably got to take a closer look because you've got, the rest of the pavement looks like it's a pretty decent shape, but looks like this one longitudinal crack runs the entire length of the pavement. You've probably got some sort of load-related distress here. And so you're going to need to do, you're going to have to do some structural evaluation, and you're going to need to look at your drainage. So, but in any case, this is well past, being a crack repair candidate. And then in terms of your materials, filling, you're going to be using your conventional materials, as we mentioned. And then on the sealing side, you're going to be using modified materials, typically modifying with a polymer, and that's going to give you the ability to, for that material to move with the movement of the crack. In terms of your configurations, there's three standard configurations we typically see. You've got your flush fill where you're sticking the nozzle in and just getting as much juice into the crack as you can. You've got your overband where you're leaving a thin film of material on either side of the crack. And then you've got your reservoir, which you typically use with a sealing operation, where you're cutting in a nice rectangular shaped channel, nice clean sides, and that gives you a lot of clean surface area for that modified material to stick to. In terms of what you don't want to see out there, you don't want to see this pond of asphalt like this. And if you're a motorcyclist, yeah, this is your worst nightmare, especially since you're not going to see this pond of material because you're coming right out of a curve. And you can tell there's a lot of vegetation that looks real damp around this section of pavement. Once you get that pond of material damp, it turns into an ice rink. And last thing you want to be hitting on two wheels. I was a motorcycle rider when I was a young lad, and this scared me as much or more than seeing a deer or a big chunk of loose gravel in the roadway. So we worked real hard in the 90s to revise our specs. We saw a lot of this in the early 90s on our DOT highways, and we worked real hard to get our specs changed so that we wouldn't see these anymore on DOT on state highways. In terms of your construction operations, pretty straightforward. Cutting is optional, but typically recommended when you're doing sealing. Cleaning and drying is probably the most important of all of your activities. Material installation, finishing, and blotting is optional. In terms of your cutting, you can either use a saw or a router. In this case, they're routing out the crack. Cleaning and drying, this is a typical setup you'd see, air compressor. The only problem here is I don't see any evidence of a oil water separator mounted on the unit. And the last thing you want to be doing is blowing in any kind of water or oil droplets into a crack that you're trying to clean and dry. And this is another unit that you could use to clean and dry. Typically, it gets a lot of use on our projects. Use of a heat lance. It's an oversized propane torch on a stick. A lot of times you'll see it mounted on a shoe or a block, like in the picture, and that gives the operator a lot more mobility, and make sure that the end of that lance isn't too close to the pavement, because if it's too close, you're going to be burning or scorching that pavement, and that's just going to be breaking down the crack. In terms of what happens when you don't appropriately clean and dry, that material is going to pull right out. Here's an example of a typical melter rig you'd see for a crack repair operation, but there's all different kinds of configurations, but this tow behind unit is typical of what you might see on a job. In terms of your application unit itself, you can usually see a disc like this, especially when you're doing a routing and sealing operation. It allows you to get a lot of material into that channel, and then leaves you that nice thin film of material on either side of the crack. And here's a low tech but highly effective way of finishing. You can take a standard squeegee, take the end and create an inverted V, and then rub that V end, take that V end and squeeze down the placed material into the crack. And the result is pretty sweet. You've got a nice little recess in that material that's in the crack itself, and then you've got a nice struck off thin film of material on either side of the crack. That's a perfect looking job. In terms of blotting, that's always a little bit controversial. Back in the good old days, folks would maybe use toilet paper. Blotting, the idea of blotting was to protect the newly placed sealer from getting trapped by traffic. You'd throw the toilet paper down, but then you had a pretty ugly project as that toilet paper was getting ripped up by traffic. Then some agencies started using some fine aggregate to protect the surface. At DOT, we don't allow the use of that fine aggregate. We'll allow you, if you are concerned about tracking, you can spray it with a cool spray of water, and that'll harden up the surface to prevent you tracking. In terms of your weather, just to close things out, you want it pretty nice conditions. You want that temperature, both your pavement and your air temperature, to be above 40. You want your humidity below 80. You don't want it swampy or soggy, otherwise it's going to impair the ability of that material to stick to the sides of the crack. And you definitely don't want any chance of rain. At DOT, we always look for a window of 2 days before and 2 days after, which would optimize our crack repair operations. So let's finish up with a little question. Which is the most appropriate way to treat moving cracks, crack filling or crack sealing, and why? Let's see what folks think. Yep. Anybody got the why? Yep, sealing. Yeah, very nice. Sealing, flexible. I think we've got it. You want to be putting that you want to be sealing. You want to be putting that modified material in there because that material is going to be able to move with the movement of the crack. Excellent. Great. Thank you. All right. Let's move on to our second technique. Let's talk about patching, and we cover that in Chapter 7 of the workbook. All right. And this slide really tells the story. Everyone pays for potholes. And if you ever left your muffler, or even worse, your tire or your axle in one of these big holes, you're not a very happy camper. So, patching why? A lot of times we're addressing a safety hazard. You got to get in there and make it safe for the traveling public. You're also repairing that localized distress. Sometimes you're trying to improve the roughness or the ride quality of that pavement by doing that patching operation. In all cases, you're reducing the rate of deterioration. You're trying to keep that pavement in decent shape until you can get them, a more permanent fix. And then sometimes you're even repairing your pavements prior to an overlay. You want to be taking care of stuff that looks like that picture. So in terms of patching types, you've got a couple options. You've got your semi-permanent patch, which you'll be doing during the construction season when the hot mix plants are open. Got spray patching, which is not widely used, but gaining popularity. You've got demand patching, which is our typical off-season demand patching, pothole patching. It's what, probably the main thing we've been doing for the last couple of weeks. And then mastic patching, which is relatively new, starting to gain use across the country, and I think we're going to start to see more use of mastic in New York as well. All right. So in terms of our summer permanent patches, again, that's when the plants are open, you're cutting your boundaries, you're getting out the old material, you're cleaning and repairing your foundation as needed. The most critical step, you've got to be applying tack coat. You're going to fill the hole then with patching material, and you're going to clean it up and move on to the next one. So in terms of cutting your boundaries, pretty important as well. You've got two choices. You can cut your boundaries to follow the edge of your distress, or you can cut a nice clean rectangle. And we strongly recommend cutting that rectangle in, because if you're trying to follow the edges of that distress, you've made a whole lot of extra work for yourself, maybe saved a little bit in materials, but it's a whole lot more in time and effort. So just as an example, not quite sure what they were thinking here. Would have been pretty easy to cut in a nice rectangular patch. Instead, they got a lot of jogs, a lot of corners, and this is going to be problematic because maybe you saved yourself a little bit in material. You cost yourself a heck of a lot more in time and effort trying to saw that, saw all those corners in, And then you're going to have a problem. You've created a whole bunch of weak spots. Every one of those corners is difficult to compact. And you've already introduced some weak spots in the pavement that you're going to have to keep your eye on. So in terms of marking out, here's a typical alligator patched area that you'd want to repair. You could mark it out, the dotted line around the edge of the visible edge of the distress, but you really want to get 6 to 12 inches out, to create your rectangle. And you do that because looking at a cutaway view, while you see the visible edge of distress, underneath that surface, you've got a lot of area of weakened pavement because of that, because of the hole in that pavement. So you really want to get 6 to 12 inches outside of the visible edge of distress. You mark out, you make your cut, then you remove your material. In this case, we had some problems with the foundation material, so we had to get down into the sub base. You can do that any number of ways. In this case, they're grinding it out. The one thing we strongly recommend is you don't saw cut it and then try to peel that pavement out with the bucket of your loader, because all you're going to do is crunch up that pavement more, and you're going to make a great big mess. Then you're going to clean and repair it. You've got some new granular material in there. And then the key, you've got to apply tack coat. You got to apply it liberally to all your surfaces, both the bottom and the sides of that new cutout, because that's going to be the key to success. And here's what looks like a pretty decent patch. However, if you get close, that wasn't tack coated. And now, instead of fixing a pavement problem, you've created yourself a maintenance headache, because you've now introduced a man-made crack, and all that water and debris is going to be finding its way right into that spot, and you're going to be having to deal with it for the life of that pavement. So tack coat, fill the hole. Make sure you've got a 25% extra. You always want a 1/4 of an inch for every inch of compacted depth, just like you would on any paving operation. You can compact using a handheld vibratory tamper like this. That's okay for small holes or thin lifts, but any kind of larger hole or thicker lifts, you really need some sort of roller. And then voila, you've got your finished patch, nice and cleaned up, and you move on to the next spot. So moving on to our next patching option, spray patching, not widespread in New York, but technology is evolving, and I think we're going to see more and more use. Let's do a quick show of hands. How many folks have experience with spray patching? David, have we got anybody?
3 so far.
Oh, wow, that's great. Good. And if you would, in the Q&A, don't have to identify yourself, but give us a sense of your experience with it. Did it work well? Did you have problems? Just a generalized sense of experience. So I jumped ahead. I was going to ask everybody else. I should have done the poll EV. We've already got the answer. A lot of people are saying no, but it is something you want to be familiar with, because I think we're going to see more and more of it in New York State. Pretty straightforward process. Like we said, some use in New York. In terms of process, it's real nice because it's a self-contained unit. And so you're blowing out the hole, then you're going to switch over and you're going to be spraying in a spray of tack coat. Then you're going to switch over again. You're going to blow in a mixture of aggregate and binder. And the beautiful part here is you're spraying with high velocity. So it's self-compacting, and you don't have to come in and roll it or compact it. And then if you've got a little bit of liquid on the surface, you can make another spray, and you can top off with aggregate. So you've got, it's an all-in-one operation, and you blow it in. You can do it almost all year round, and then you're moving on to the next set of issues.
Just so you know, John, we had one comment that yes, it works well.
Oh, fantastic! Glad to hear that. We're going to, before the workshops, we're going to want to talk to that responder. Thank you, David. In terms of demand patching, well, that's typically our bread and butter. That's what we typically think of it when we talk about pothole patching, and I think everybody in the audience can relate to this. We're always doing it in probably the most challenging conditions. So why do we do demand pothole patching? Let's just take a crack at some answers. Absolutely. Absolutely. Everybody's got it. Safety first, save mufflers. Absolutely. Rideability. You got it. Everybody's tuned right in. All right. So talking quickly about our pothole patching, why it is our most common pavement maintenance technique. We do it primarily to resource safety, and to reflect that, many agencies have a 24-hour standard patching potholes. Ed Dennehy, my colleague in maintenance when I was at DOT back in the 90s, and I worked on a project. We developed and implemented the 1-800 pothole system for New York State. Believe it's still in use, and I believe right now if you make a call in with a pothole, it'll ring into the local residency, and they'll get right out and get that pothole filled. So in terms of techniques, there's two particular techniques we're going to talk about. The one we want to focus on, the one we strongly recommend is the throw and roll. And you're going to be using most of the time modified materials, and we'll talk a little bit why that's so important. We definitely strongly discourage you from using throw and go. And it doesn't matter what material you're using, but primarily you'd be using conventional materials. We would strongly recommend you don't use that approach. And in all cases, your underlying distress is not repaired. You're going to be needing to make some permanent repairs when the weather gets better, when you get into the construction season. So in terms of throw and go, here's a typical example of what we would see and what we would be trying to fix. Again, we'd be looking at using conventional materials. And the thought here is that the traffic is you're going to be throwing the material into the hole. You're going to be whacking it with the back of your shovel, maybe. That's going to be the extent of your compaction. And then you're hoping that traffic is going to compact it for you. And I do say hopefully, because typically it ends up looking like this. That material stays in that hole for about 5 minutes, and then you're back to the same situation as you had before. So you accomplished absolutely nothing with all that time and effort in resource expenditure. So what we really strongly encourage is the throw and roll technique. You want to start out, get as much water and debris out of the hole as possible. It's important, but not critical. You're going to hit it with a shovelful. You're going to fill that hole with your modified material. If you take a close look at that material, you can see it's glossy and looking sticky as can be just from this picture. And it really is. That stuff is highly juiced up. It's already compacting under its own weight in that picture. But then here's the key. You back up with your truck tire, you hit it, get that nice and compacted, and that's critical, because that the force of those high pressure tires, you're squeezing that material together, and what that's doing, that force is activating the polymers in that mix. So that stuff is like super glue now. And then you pull back forward, and you've got your finished pothole. And that's the only thing I'd do different here is I'd hit it one more time with one more back and forth, get down, knock off those edges. But you've got a pothole, a filled pothole that's going to last you for the rest of the season. And then just as a quick snapshot, this is a demonstration that we would do in the workshop. On the left is your throw and roll. On the right is your throw and go. To simulate the throw and roll, we tap it down with the end of the hammer just a little bit on the left-hand side. You turn those pans over, and already at 26 seconds, it looks like that throw and go is falling apart, and you get to 5 minutes and it's out of the hole. Whereas on the left-hand side, that if nothing else, that throw and roll is continuing to compact under its own weight, and that's a nice tight filled pothole that's going to take care of you for the rest of the season. All right. Another question: what do we do if we have a long section of roadway with large cracks? So you've got that, these are running, you've got a whole lot of, this large cracking, 1 inch wide, with high levels of edge deterioration. They're falling apart, but you really don't have enough money to do a pavement rehab job. What would you do? And the folks that are answering, my favorite answer, come on, let's have more of it. Come on, I'd be crying. Looks like other folks are really tuned in. Crack sealing, while I like the answer, it's not going to work. you're talking about highly deteriorated 1 inch, over 1 inch wide cracks, and that sealer is really not going to be effective. It's going to be tearing apart. So
John,
the other is light.
you had some other answers in the Q&A. Several people put mastic, some people put limited cut and fill, and a couple put microsurface.
Oh, interesting. Well, how would you respond to those answers, David?
I'd have to see the pavement to be sure and know what's going on underneath. Somebody mentioned base repair. I really want to know what the base was. Mastic might work if it's not deteriorated under the base, but the key in all these things is you got to get out there and you got to see what the field conditions are and check the drainage.
Absolutely. I'd say microsurfacing is probably a little on the outside edge of this. I don't think I'd try to tackle it with microsurfacing with those big cracks, but mastic definitely an option. And then any of the more extensive repair type efforts also need to be considered. So let's talk about mastic. Who's used mastic? Take a quick look. All right, good chunk of folks have not. So let's blow through this real quick. And I see I'm running a little late on time, so I'm going to turn up the heat a little bit. All right, mastic is got some growing use in New York State. It's been used for a long time in limited amounts across the country. It's a hot poured liquid modified asphalt. You can think of it as crack sealer on steroids, and the key here is it's pre-mixed with a light rate aggregate. So it's almost like it is almost like a concrete. You're using it where your pavement is highly deteriorated, where your cracks are greater than an inch, or you've got extensive alligator cracking. It does need to be clean and dried, but you can apply it when it's very cold. I've heard of, talked to some folks who said definitely below freezing, and you can get it down. You can use it down to 0. It's just charged out of a chute from a melter unit, so it kind of looks like a ready mix operation. You can either pour it directly into the hole, or you can pour it into a wheelbarrow or a spreader, and you can spread over the crack using a drag box or a squeegee. It is still evolving in use. Some initial standards have been developed by ASTM. They still typically refer back to the manufacturer's technical specifications, but they're continuing to evolve, and I expect to see much more comprehensive standards in the future. And in terms of what it looks like, on your left, you'll see your chute. It's discharging that highly modified material into that spreader box, and then they're just running it over that routed crack. And here's a case of that big honking hole that you want to fill. And again, this one ran all along the edge line. And again, using probably a drag box unit of some sort, they've got that hole nicely filled. So
notice, John, that's nice and dry in there. That's a key with the mastic. There's no water problems underneath. Absolutely.
It's back to David's point. You got to do some further investigation to make sure you don't have any drainage problems. So mastic is good. We're going to see more and more mastic, I believe, in New York, and just wanted you to be familiar with it. We'll talk about it more at the workshop. In terms of thin wearing courses, this is something I believe we're all pretty familiar with, Chapter 8, the workbook. So we're going to go through these real quick. Why do we install our thin wearing courses? Just see if we get a couple responses. Well, I'm going to beat you to the punch. Why do we do thin wearing courses? We do it to seal and protect our pavements. We want to be able to cover our minor cracking, primarily to prevent water penetrating into the pavement. Sometimes we're doing it to provide or restore our skid resistance, and many times we're doing it to restore an oxidized surface that's aging or weathering, or it's being distressed by solar heating and all those kind of things, environmental issues. And then sometimes we even use it to fill minor ruts. So here's an example of a perfect candidate. If your pavement surface beads, if you got a rainstorm and your pavement surface is beating up the water and it's rolling right off, it's not ready for a wearing course or a seal coat yet. But if it looks like this, if you've got this nice salt and pepper mottled look, that means pavement water is getting into is penetrating the surface of that pavement, getting into the pavement section, and it's time to get a wearing course on it. And this is especially good because you don't see any kind of cracking or other distress. So got a whole bunch of different kind of wearing courses. You've got some emulsion based. These are your conventional sand seals, chip seals, and slurry seals. Then you've got some specialty treatments, microsurfacing, which is a 2-pass system that was developed in Germany. This is emulsion-based. It's a juiced-up slurry seal. Then you've got your NovaChip, which is a specialty treatment, again, developed in Germany. And this is a combination of a seriously juiced-up emulsion and a polymer-modified hot mix. And then just to finish off, we've got a hot mix, our thin hot mix 6.3 overlays, which are becoming much more popular in New York State. And so just a quick look at these. Here's a sand seal. Just notice the nice brown color of the emulsion in front of the spreader. Here's a chip seal. Notice the nice chocolate brown color in front of the spreader, but also notice that the chip aggregate spreader is tied up to the to the liquid distributor. Slurry seal, nice brown color coming off the back of that screed, all in one unit. The conventional materials. Microsurfacing is our slurry seal on steroids, using a polymer modifier in this case, and you're running it in 2 passes. Here's just another picture of microsurfacing setup, and a nice look at the screed. And here's an important thing about microsurfacing. It was developed in Germany to deal with ruts on the Autobahn, and you can see all these nice channels in the wheel pass. So what they do is they put a V-shaped unit, 2 V-shaped units in the back of the screed, and that channels the microsurfacing material into those ruts, and it fills them right up to the existing surface of the pavement. So you make that rut fill pass. That's what you see on the right-hand side. Those two nice black lines, and then over on the left-hand side of the slide, you see they placed a finished pass. That's their second pass. And that's your new wearing surface, or your surface coat. Real nice product. And moving to NovaChip, again, a specialty product. The beautiful part about this, again, it's a all-in-one unit, and you get a real nice, sweet, very thin surface. It's really a chip seal on steroids, almost one stone thick. I mean, notice that really gooey looking chocolate brown liquid that's below the aggregate. And that's a key to success. That's a highly polymerized tack coat. And that once that hits the polymer modified hot mix, you got it super glued. And this is just a look at the screen, and it's got a built-in spray bar. So right in front of that hot mix, you're spraying that juiced up tack coat, and you've got an unbelievable armor coat. And then last but not least, our thin hot mix overlays. That's 6.3 mix that we've been using probably for 10 to 15 years at DOT, coming very popular as a wearing course. And you can get it down 3/4 to an inch thick, as compared to 1.5 inches for our normal 9.5 and 12.5 mixes. And you get a beautiful surface. So like you see in the right-hand part of the slide, for any of the old timers, looks just like our old 7F mixes. So which of the following, let's ask a quick question, which of these following wearing courses are appropriate for filling ruts? Well, while I'd like to say that the answer all of the above is correct, nope, not quite. Absolutely, microsurfacing is, and anybody that answered NovaChip looked ahead on the slides. And here's just a quick summary of the performance characteristics. You can seal and paint. Everybody seals and protects. They improve skid resistance. They restore an oxidized surface. Microsurfacing, yep, you can get up to 3/4 of an inch. That was what it was originally designed to do. And because NovaChip has got such a juiced up surface, or such a juiced up set of materials, you can get up to a 1/2 inch in ruts. Not typically used to do it, but you can. So let's another question. When applying our emulsion-based treatments like chip seal, you want that emulsion to be a deep black color prior to applying the aggregate. All right, I think most everybody's on board. No, you don't want it to turn black. And we'll talk about that for a second, but I do want to quote David. If it's brown, put it down. If it's black, take it back. And here's why. So your emulsion is really a suspension of minute, tiny asphalt droplets that are blended into water, and that's what gives it its nice brown color. That's a suspension of the asphalt in the water. And that emulsion is attracted to and bonds to, it coats that aggregate. But once that emulsion is in contact with the pavement or the aggregate, it's starting to break. That is, that water is separating from the asphalt and it's turning black. Once it breaks, it's no longer able to bond to the aggregate or the pavement. So just a cutaway view, you've got your emulsion, nice suspension, that's your nice brown color, chocolate brown color. Once you start breaking, that's breaking it back into your components of water and asphalt, and that's why you're seeing that black color. And then once it's cured, you've got your hardened liquid asphalt. Now, again, it's hardened asphalt. And here's a case of it's too late. That emulsion is black already, and there's no way that aggregate's going to stick to the emulsion. Another case of too late. Looks like they're going to town, but that emulsion's black, and it's that aggregate's going to not last there very long. So you've wasted a whole lot of time and resource. And here's an example of a beautiful finished product. I believe this is a slide from David. I believe it's a double chip in someplace out west. And that's exactly what you want your finished product to look like. Looks like a brand new paved surface. And in this case, because you're using a chip, you're getting it for a lot less money. So
it's a National Forest Service road, John.
Awesome. Well, it's a beautiful project. Love it. Love that picture. Thanks, David. All right, we're going to do a quick exercise in the last 5 minutes. It's called Choose to Repair. We do a little bit more of this at the workshop. We're going to give you a picture. We're going to ask you to go through the observation, analyze, and evaluate process. We're going to give you your menu of repair choices, and then we're going to ask you what you think to the pavement. So let's start right off. All right, let's put them into the Q&A. Your answers into the Q&A, and David's going to just give us a readout of what kind of answers we're getting.
Should I play Jeopardy music?
Yeah, there you go. What do you think? Have we got some answers, David?
Not yet. Actually, I don't see any answers yet in the Q&A.
All right, so I'm gonna start leading us.
Here we go. Wearing course. Somebody said, look at the drainage.
Yep. Good.
Wearing course.
Yep. Nah, I think
Do nothing. Do nothing.
Well, I'd stay away from doing nothing, and let's talk this one through real quick. You've got a pretty serious bleeding and flushing problem, and it's not gonna self-heal. It's probably gonna get worse. You're gonna have to do something. You do need to look at your drainage. There's no obvious cracking, so you can't do crack treatment. There's no isolated areas of distress, so you're not going to be doing any patching. Definitely, you're going to consider a wearing course. The one thing you got to think about is you're going to have to alter or modify your mix design, because you've got liquid asphalt at the surface, and so you're going to have to adjust that mix design to account for that liquid asphalt. In many cases, you're going to have to think about an overlay, or depending on whether you've got some structural issues, you may have to mill and fill. We had a lot of problems like this on some DOT roads in the early 2000s, and we ended up doing a lot of 1.5-inch overlays to fix them. Potentially.
By the way, John, you got a nice recommendation. Someone here says drill a core, figure out what's going on.
Fantastic.
Part of the problem with bleeding roads is if it's being caused by vapor pressure underneath, it'll even go through a hot mix overlay pretty quickly. It may take a few years, but it'll show back up. Bleeding is really hard to fix.
Yep. No, absolutely. And I apologize for missing that. I should have known that one. So Thanks for the save, David, and to the responder. All right, try the next one. We're just going to blow through these now real quick because we're getting towards the end. We'll spend some more time at the workshops. This one's a tough one. You'd love to say you could crack, treat, or patch, but it's too far gone. You're going to have a problem with a wearing course because you're in a curb section and you've probably got drainage structures. You'd like to think about some cold in place recycling, but I bet your traffic is too heavy, especially during peak hour travel. So you're really into some pretty extensive rehab with an overlay.
We had patching, overlay, and reconstruction in the choices, but I think depends on what the structure is. This one would actually make a pretty good fill in.
Yep, the mill and fill would be
place.
my choice.
Yeah.
All right, in terms of this one, looks like somebody was already thinking about patching. The one thing we got to consider is look at those holes a little bit more. You've got standing water in those holes, and it's not evident that there was any recent rainstorm. So that water's coming from someplace, and you've got to figure out where that water's coming from. So you've got to do, like you said, some coring or a test pit. You've got to do some further investigation before you do any kind of pavement repair. And then last but not least, what would people do with this one? I hope we all answered, do nothing but plow.
Plow, plow, plow. Yes.
There we go. That's my favorite answer this time of year, although I hope we're done with that pretty soon. So real quick summary. Here's the topics we covered today. Let's go through them real quick. Why roads? We all got it. Backbone of the economy. Pavement management, right place, right treatment, right time, and right way. We want to be doing those preventive maintenance treatments, those low-cost treatments on good roads to keep them in good shape, because it is the most cost-effective strategy. If you're waiting until that pavement is in poor condition, it's going to cost you 4 to 5 times as much to get it back in good shape. You want to be doing them because you want to be addressing and maintaining the safety of our roadways, and you put it all together. You really want to be protecting the public's investment. You want to be making the best use of our limited resources, getting the best bang for our buck. That's our pavement maintenance. In terms of the tools, we talked about them a little bit. We'll talk about them more in the workshops. Hope you join us. Crack repairs, patching, thin wearing courses, all have got their place in the toolbox. I hope you continue all to use them and use them wisely. And in terms of your repair options, you've got a pretty straightforward approach. And you're going to be selecting your appropriate alternatives, but you really want to key in on, for your pavement maintenance to work, you got to be fixing the causes of your stress, not the effects, not just what you see on the surface. And the bottom line, it's our most cost-effective way of keeping roads in good shape. You've got a wide range of tools available to you. You've got to make it work. You need to fix the causes, not the effects. And as always, that first question we're asking and trying to answer is, how's the drainage? With that, I want to say thank you. I really appreciate everybody's participation today. We got a lot of future training opportunities on deck. Got a couple more webinars. David always has a lively bumper banner, Facebook Live at 11 a.m. on Mondays. Our spring workshops are open, and we hope many of you can register. We hope to see you there. Again, thank you. Really appreciate your patience today, dragging along with me, and I appreciate David and his team carrying me through this webinar. Everybody,
one more slide, John. One more slide. There we go.
Thank you. There we go. Excellent, David. See, I told you guys had to carry me. Thanks, everybody. Hope to see you at the workshop.
Have a great day, folks.